on the topic Kanakkatikāram, the history of pre-modern Malayalam mathematics. Dr. Arun Ashokan is a researcher who has completed his postdoctorate from the Chair of History and Philosophy of Mathematical Sciences, Zurich. He has been working on the history of vernacular mathematics in medieval South India. After the completion of the event, I'm sure that you all will feel enriched with knowledge on this particular topic. Before we start the session, all the audience are requested to keep their microphones on mute during the session. After the session, we will have a question and answer session. The questions can be typed in the chat box and we will read them out for the benefit of the speaker. I feel honored to welcome you all once again for this webinar. Professor Ken Ganesh to kindly take over the session. Thank you.
Yeah, thank you very much. I think Dr. Arun Ashokan possibly has less time than what he originally probably was planning. So I think I'll request him to present his paper and then we will have the discussion. I hope you will be able to finish it in about 45 minutes. I think that, yeah.
Am I audible? Hello, am I audible?
Yes, you are.
First of all, I would like to thank KCHR giving me this wonderful opportunity to present my paper on Kanakkatikāram. This paper is a joint venture of Professor Roy Wagner and me. We published this paper in History of Science in South Asia. Rather than discussing all kind of questions which we raised in this paper, I would like to present an abridged version of this paper by giving much emphasis on historical formation of mathematical knowledge in Kanakkatikāram. Let me start. Kanakkatikāram is the title of Premodern Tamil and Malayalam elementary mathematical treatise. These treatises were circulated considerably in medieval and colonial Tamil Nadu and Kerala. We will discuss the type of language, nature of content, and historical context of formation and dissemination of knowledge in Kanakkatikāram. This discussion is based on 4 Malayalam Tamilized manuscripts of Kanakkatikāram, a paper transcript, and a printed version. In Malayalam Kaṇakkatikāram, no manuscript that we know has colophon and include an attribute to an author. Therefore, it is difficult to know anything accurate about the authors or the period of composition of this Kanakkatikāram treatise. The distribution and variety of the manuscripts and the geographical spread of ecological and commercial network that carried these treatises does not compel us to assume a uniform source of origin. Instead, the linguistics, stylistics, and internal evidence of these treatises suggests that the different words were formed in different time and places and were constantly recombined, re-edited, and renewed by local teachers and practitioners who created new Kanakkatikārams. The versions of Malayalam Kaṇakkatikāram treatises which we were examined display substantial variety in content and ordering. While there are some verses that have variant in all Malayalam versions, most verses can be found only in some versions, and some manuscripts leave entire section out. The most constantly repeated common words are a couple of introductory verses and some list of unit of measurements. This variety means that we shouldn't consider the Kanakkatikāram as an authorial text, but as a genre of mathematical treatises. It is held together by a common theme and a few common verses for an apparently pedagogical purpose and context of use. Unlike Sanskrit mathematical treatises, which are generally considered to be lofty Brahmin compositions, it is almost sure that Malayalam Kaṇakkatikāram consists of contribution by people from a non-elite and lower caste background with diverging poetic skills and distinct professional involvement. From internal evidence in a verse, we can presume that the preliminary composition of these verses of Kanakkatikāram were probably happening in a period of 14th and 16th centuries, although it was sometimes continued until 19th century. For instance, in 1863, Mavanan Mappila Sayyid Muhammad prepared a new Kanakkatikāram collection. Etymology. The title Kanakkatikāram is a combination of two words, Kanakku and Adhikaram. Kanakku means calculation, accounting, mathematics. In a compound sense, calculator, accountant, mathematician. Adhikaram means topic or section of treatises, but in a broader sense, it refers to rule and official authority. Thus, the title Kanakkatikāram means topic of calculation or rules of accounting. But in an oblique reading, it also means the authority of calculation or authority of accountant. The style of Kanakkatikāram can be loosely categorized as pāṭṭu. Pāṭṭu verse, followed by prose commentaries. The level of poetic sophistication is limited. Yaduka is usually, but not always present. Mona is usually absent. Generally, the verses show a remarked Tamil influence. Philologically, the verse tend to shy away from palatalization and nasalization, where these are available in modern and late medieval Malayalam. A large number of Sanskrit words are expressed in a Dravidian orthography, as is common in pāṭṭu. The prose commentaries are comparatively less Tamilized. Kanakkusaram, Balaprabodhanam, Kanakku Shastram, Kanakku Chodyam, Ganithanul are other Malayalam elementary mathematical treatises related with Kanakkatikāram. We are not going to discuss in detail about what kind of relation these treatises have with Kanakkatikāram, because it's a very complex and very network kind of relation. we don't have much time to discuss about that. Context of Kanakkatikāram. Content of Kanakkatikāram. The content of Kanakkatikāram manuscript is loosely divided as invocation, table of content, list of fraction and large decimal powers, measurement unit, explanation of some mathematical operations, and mathematical word problems dealing with calculation of land, gold, rice, and paddy. Invocation. Invocations cite name of goddess and gods as the creators of mathematical knowledge and pray to them for aiding to understand and recitation. Very few of the invocations cited celestial rishis, legendary figures like Agastyan, unnamed masters and gurus as mediators of this knowledge. But these spiritual figures are almost absent in the rest of this treatise, except in very few word problems presented in divine settings. Table of content. This table of content lists subject covered in the treatises such as land, gold, paddy, rice, wood, volume, and weight, and enumerated the number of verses in each subject and state the total number of verses in Kanakkatikāram as 60. Most importantly, the subject and numbers of verse stated in this content verse do not fit any of the available problem section. This is a clear indication that the manuscript are ad hoc compilation rather than authorial creation. Fraction and large decimal powers. The verse present fraction and large decimal powers name the standard fraction in Tamil Malayalam system. In this system, 1/2, 1/4, 1/20, 1/80, 1/320 are the fundamental fractions, in the sense that the name of other fractions are derived from them. That means Kali, Ara, Mukkal, Arekkal. These are the Malayalam kind of name of these fractions. Composites are generated by adding and multiplication. Then the same scale of fraction is applied to 1/320 and sometimes 1/320 into 1/320. The large fraction of the scale is divided into 21 parts and then to 7 parts, yielding the fraction called Anu. Then begin several alternative scales that are further divided Anu into subunit. None of these minute divisions are useful for calculation. None of are actually used in problem section. Note that the Malayalam number notation does not use 0. So large number has to be given specific names. All Kanakkatikāram has unit of measurement, scales of units of weight, volume, time, and distance. This list contains a realistic range where the various versions tend to be more mutually consistent. But the consistency among a small number of realistically measurable traits were lower. Even the realistic range, only a few of the units mentioned in these sections are actually used in problem sections. And the problem sometimes refer to units that are not mentioned in the list. Yet another indication of the combinatory nature of these treaties. Explanation of some mathematical operations. The words present explanation of some mathematical operation offering some mathematical tools for calculation method. They sometimes begin with the list of name of basic arithmetical operations. That means addition, Kutuga, subtraction, Kalayuga, multiplication, Perikuga, division, Ikuga, squaring, Varkuga, cubing, Kanikuga, and their roots, Muluga, as well as the Samgalida, sum of infinite series. Another topic is the rule of three. These rules answer the following questions. If a unit of money or a commodity yield B, unit of some other money or commodity, how much of the latter would C of the former yield? The answer B into C divided by A is usually present in terms of uniquely Malayalam terminology. Talla for A, Pilla for B, and Peruval, expecting mother, for C. The expecting mother is then supposed to produce a son in analogy to the relation between original mother and son. Word problems. The word problem covering following topic: commodity exchange and price calculation, gold evaluation, wood measurement, land measurement, rice or paddy calculation, some kind of Pythagorean theorem, interest calculation, and a specific kind of recreational problems. Most of these problems are present in terms of everyday crafts and commercial practices, including some words that introduce a relevant craft. That means explaining how to melt and assay gold, or how to saw wood. Altogether, the content of the problem section is in the line with so-called practical recreational mathematical treatises in India, Mesopotamia, Egypt, China, Arabia, and Europe. However, these problems are set within the specific socio-cultural and cultural framework of the Indian and Kerala mathematics. In the historical context of formation and dissemination of knowledge in Kanakkatikāram. From situational evidences and textual remarks in the Kanakkatikāram, we can understand that the Kanakkatikāram of these knowledge of these treatises were evolved and spread through interconnected network of historical contexts. Those interconnected network of historical contexts are education, trade, performance, production, and nature. Education. Sandil Babu placed the Tamil Kaṇakkatikāram in the context of teaching in village school. Instead, the Kaṇakkatikāram appeared to have been used in second standard of a child mathematical education. after they have mastered the injury multiplication table and some basic arithmetic. This is corroborated by the fact that at least 2 of our manuscripts are bundled together with an injury, and the only elementary mathematical operations explained in the Kanakkatikāram are fraction multiplication and the multiplication of higher decimal powers. Moreover, C.K. Moses claimed that Kanakkatikāram problems were used to teach mathematics in the early 20th century, as reflected in the memoir of E.V. Krishna Pillai. The caste and professional composition of students of village school may have depended on the time and place. The teaching profession was associated with such castes as Eruthachan and Panikar or Kaniyar. They belong to lower levels of Jati hierarchy or fall outside it. They seems to have been considered polluting caste, assuming that village school teachers were indeed actively creating or recreating Kanakkatikāram verses. The relatively low position of its authors may explain why we do not find reference to caste hierarchies in Kanakkatikāram. The diverse setting may also explain variety of versions and corruption of Kanakkatikāram text. The text of teachers of various middle and lower caste may have excluded, revised, or created verses to fit their pedagogical purpose. The manuscript's preparation may have served a memorization aid or a proof of graduation. Moreover, village schools were highly independent institutions, not subject to any centralized hierarchy. The highly localized setting have involved a focus on specific craft, which lead to the inclusion or exclusion of some families of problems and techniques. In such settings, the grammatic and schematic quality of the text might not have been terribly important, and long chain of uncoordinated teacher-student transmission may account for the diversity and sometimes poor quality of these texts. Trade. Another context of understanding Kanakkatikāram is that of trade. A verse in Kanakkatikāram named 6 Kerala trading centers: Kochi, Kozhikode, Ponnani Veliyangode, Palayur, Kulamukkam, and Palakkad. In history, Kochi, Kozhikode, Ponnani Veliyangode were the largest pre-modern ports of Kerala. Moreover, Ponnani Veliyangode marked the presence of large Muslim community. Palayur noted the settlement of Christian community, and Kulamukku recognized as the host trading centers having presence of Tamil Chetty and strong trade link with Karnataka. As I marked in the map, this list of trading centers may have been selected for this verse because it designated the nodes of trajectory of an itinerant trader with contact in various trade communities. This putative trader would travel along the Bharatapuzha river from the Palakkad Gate via Kulamukku to Ponnani Veliyangode and via the backwater and the coast to the Palayur, Kochi and Kozhikode. This travel route I tried to map in the map which showed in the PPT. Such a trader may belong to various caste and religious groups. With the collapse of large trade guild around 13th century, the trading communities become more diverse and dispersed. Perhaps training and education follow this decentralizing trend as well. This may explain the emergence, distribution, and diversity of Kanakkatikāram manuscript. Moreover, the Bellad Payyanur part describes the knowledge that a trader's son must master, which include calculation related to gold, silver, money, loan, measurement, gem, land, and seed, all of which are dealt with in our Kanakkatikāram. The reference to rent or taxation is a handful of problems. The reference to rent or taxation is marked other figure related to the commercial context. Kanakkupillai, Menon, Poduval, and Taragan, who were working in the service of landlord, temple, or political administration, managed inventories, rent and trade tax collection. Beyond general mathematical education and training of merchants, Kanakkatikāram may have been particularly important for the training of these accountants. But the deficiency of references to rent or taxation may indicate that the treaties were more oriented to commerce and general teaching than to administration. Performance. Yet another relevant context is that of literary performance and challenges. Words that purport to share knowledge were not only vehicle of the preservation and dissemination of knowledge, they were also vehicle for providing one's literary veracity. Several Kanakkatikāram words are stated as challenge to the listener, using formula similar to if you are a good calculator, say. At least one version of verse explicitly suggests that being able to recite conversion rate between capacity and weight for various substances is a proof of one's status and official position. In the context of Shastra Pāṭṭu, that of martial arts song, G. Trivikraman Pillai document precisely this phenomena. The ability to chant some arcane technical words would prove the performer's proficiency. In the specific context of Kanakkatikāram, C.K. Muhsad claimed that some of the problems are more about teacher expressing prestige, arcane knowledge in order to gain veneration than about actually teaching the student. We note that the inclusion of arcane and partly esoteric knowledge by teachers, as well as culture of challenges between mathematicians and students, was also part of late medieval Kerala and Renaissance Italy. The dimension of performance highlights the tension between the written and oral text. It invokes improvisation, adopting the mathematical knowledge to different contexts, which may lead to new or revised verse in the written text. Network of production and nature are two other influential historical contexts of Kanakkatikāram. Substantial verses on the calculation of land, paddy, rice, wood, and gold show how the knowledge of Kanakkatikāram have emerged from the interaction between the production process and the dynamics of ecology. Production. Considerable number of calculation problems in Kanakkatikāram describe the process of production, distribution, and exchange. For instance, it asks, after threshing 100 idangari of paddy, how much rice one could get. Moreover, a problem asked to Kanakkar, that means accountant, in the storeroom. A problem asked to Kanakkar in the storeroom to calculate the amount of rice produced out of paddies having different paddy rice ratio, which are brought by a trader, chetty, after boiling and husking. Another paddy problem asked to answer the Nari Para ratio for the repayment of a paddy loan, where loan approval and repayment fixed in a different Nira Para ratio. Here, the production of rice from paddy is represented through the actions of boiling, threshing, husking, cleaning. Similarly, the system of distribution and exchange is clear in these examples. The examples present remarks about accountant, trader, and the measurements, the calculation of paddy rice ratio, the conversion rate between different Nira-Para ratio, the practice of paddy loan, and the mode of exchange of paddy. The problem of wood calculation and gold calculation present two different kind of networks of production, which reveal the contribution of production process in the emergence of mathematical knowledge in Kanakkatikāram. For instance, the network of timber production show the involvement of tree, wood, carpenter, sawyer, timber, handsaw in the formation of measurement units, procedures, and rule of wood calculation in Kanakkatikāram. Nature. Woodland such as forest and plantation, and the paddy land such as wetland and dry land were the ecological agent who relationally produced the knowledge concerning wood calculation and paddy calculation. For instance, one of the calculation problem depicts in a land where pala grow in the soil, in a plot plug after heavy rain, someone sowed one column of seeds. The sparrow picked up all of them. While the sparrow picked up the seeds, the owner pursued and at once threw a limb of earth. It hit the sparrow. While that sparrow was dying, it said, I am only got 3 seed grains. Therefore, if all the sparrows each got 3 seed grains, say how many sparrows together completely pick up these seeds. In a literal sense, this is a calculation riddle in the form of a story about a farmer whose seeds are stolen by birds. Indirectly, it is a cognitive event which illustrates the environment of rice cultivation with its interactive natural and social grounds. how interaction alone is not enough for growing paddy, how intention alone is not enough for growing paddy. The first lines signify how mutually interacting factors like ecological force, fertility of soil, hydrological flows, heavy rainfall, paddy, property of plow, force of animal, force of plowman, and vitality of paddy are co-constitutive for growing paddy. Neither human nor the non-human designate a prior position over that of other in the actualization of the human intention to produce paddy. Here, human cognition concerning cultivation is a distributive and emergent product of a network that exists between human and non-human. If we take the case of paddy, it is an organism having capacity to grow in a suitable environment and a vital nutrient significantly help man and other creatures to grow. The paddy designates double force in the network of paddy cultivation. Both the picking up of paddy by the sparrow and the throw of the earthworm by the owner are enacted under this double force of paddy. This double force may be contribute to make paddy measurable and measuring entity at a time. Because in Kanakkatikāram, paddy is a basic unit of weight, length, and capacity in the scales of measuring. The corresponding ratio of paddy with the unit of weight, that means a paddy ratio with the pepper, the unit of length, paddy's ratio with the finger, and the unit of volume, chavadu, that means paddy's ratio with the chavadu map a co-constituted network of measurement among paddy, body, and brain. This shows the relational agency and material meaning of paddy behind the emergence of knowledges in the Kanakkatikāram. Thank you.
Okay, thank you very much, Dr. Arun. I think there will be, of course, there is one question in the chat box already. You can go through it. Or will Dr. Bashayab speak it? Read it out.
It would be good if someone could read it.
Yeah, she will read it out.
Sir, at present we don't have questions on
There
the chat
seems to be a
box.
question now. Chat box, there is one.
Oh, yes. Yes, we have seen. We will read. Question by Madhu. How did the script vanished? How did the script vanished?
Which script I didn't get actually. Pardon?
Is the question typed on the chat box?
Because it is similar script to the contemporary Malayalam, but it is in this pāṭṭu style. That means, as we know, Dravida Sangakshara Nibidha Yaduga Mona Vishesha Yuktam pāṭṭu. That Sangaksharangal is only available in that actually. That is the limitation of that language.
One more question.
Mm,
Yeah. Another question by Vijay Kumar.
mm.
What is the message that you wanted to convey? Any recent research in this point?
It is a very complex question and plain too. Uh, Actually, to understand our present, uh, to understand our uh, being in a very complex sense, we need to understand how our present is formulated through the production of certain kind of knowledge. In that level, we need to do serious kind of research on medieval or this kind of historical period. It is not to kind of attempt to find out the lofty origin of Malayalis. Instead, how complex our genealogy of knowledge, how complex our being itself is the thing which we can see while we are doing this kind of research. This is the one of the large vantage point which I kept in mind while doing this kind of research.
Another question by Pramod Sakharkar. Is it possible to integrate in NEP today?
That I don't know actually. You need to think seriously on that. No one I cannot answer that because it is the question which should address by pedagogists, I think.
Another question by Renu Abraham. Thank you, Arun, for the fascinating presentation. I have a couple of related questions. Why were the treatises written in the pāṭṭu form? Did the treatises have a performative function only, or did it also have a record-keeping purpose?
First of all, in medieval period, much of the written documents are in poetic rather than prose form. Perhaps it was the dominant mode of articulation of that period. We cannot answer in a very categorical sense. What is exactly the causality of using this pāṭṭu kind of writing style or articulation style or performance style? There are different kind of context may influence that kind of formations.
One more question.
Other questions?
I'll
There are
read,
two
sir.
more questions there.
Yeah, sir. It was not visible on my screen. What are the continuities and departures you see in mechanisms of mathematical knowledge production in the colonial times from when the treatise was originally conceived?
Continuities and get exactly. Can you please?
What are the continuities and departures? Departures you see in mechanisms of mathematical knowledge production in the colonial times from when the treatise was originally conceived.
There's a, if we address this question in a very historical sensibility, there is a continuity, of course, of knowledge, because we know that the Ara, Kal, Arakyal, Mukkal kind of calculation methods, call instead of meter and other kind of viral, whole kind of measurement units are still used in contemporaneity. In that way, there is a continuity, but it is not a continuity in a strict historical sense. Perhaps it is a discontinued continuity if we consider. If you want, you can call it as a discontinued continuity, I think. Departure means perhaps the colonial modernity reframed the pedagogical practice, because it is, first of all, it is centralized. Second, it's standardized, and it used what is the interesting thing is that it used so-called modern kind of knowledge perspectives to understand, interpret the traditional kind of knowledge.
Another question by Afif Ahmad. Were you able to check the litho copies of Kanakkatikāram along with manuscript that you had accessed? If yes, were there any attempt to standardize evidence in the lithos as it were used for pedagogical purposes?
Lithos means what it is actually? Can you explain?
It is written in such form, that is LITHO, lithocopies.
Lithograph print.
Oh,
Yes, certain lithograph print afterwards.
okay. I don't know exactly about that because I haven't viewed lithograph prints and all.
Another question by Rajeshwari.
Sorry.
Another question. In connection with the School of Kerala Mathematics, livelihood-based wage or remuneration calculations, any hint in this book, Kanakkatikāram and related treatises?
Actually, the trajectory of this higher order mathematics and popular kind of mathematics which deal in Kanakkatikāram perhaps different, but at the same time we can see certain kind of mathematical problems which discussed in Kanakkatikāram as a relation with infinite series. For example, we have a kind of infinite series. You know that infinite series and heliocentric models are the two of the major contribution of Kerala School of Mathematics. So in Kanakkatikāram, we can see Sankalita. Sankalita is a kind of a preliminary method to calculate infinite series. So these kind of things we can see in Kanakkatikāram, but we don't have a profound or powerful source to make a constructive link between Kanakkatikāram treaty and Kerala school, because Kerala schools going in a kind of a quote-unquote higher order mathematics.
Next, another multiple questions by KG Sheshadri. First one is there any evidence in the text that some problems are derived from earlier Sanskrit texts like Leelavadi, Brahmagupta's texts, etc.?
Actually, many of them believe that Kanakkatikāram kind of vernacular texts were the derivative of Sanskrit canons, canonical Sanskrit mathematical text. But in our research, we found that the Leelavadi kind of text has a very minor kind of influence on Kanakkatikāram. Very few word problems that written in a very that deal the recreational problems are present in Kanakkatikāram, which have a certain kind of a relation with the problems which discussed in Leelavadi. That doesn't mean that Kanakkatikāram is derived from the Sanskrit canon, because if we compare with the Kanakkatikāram Tamil and Kanakkatikāram Malayalam, the similarity is very less actually, because the formation of a problem so in a expressed in a very different settings and different style.
Second question by himself. Is there any evidence of archaeological practical use in Kerala that we find that the text was in wide use in parts of Kerala?
There are no, as I read in my paper, Musa, who wrote a traditional mathematical text in Malayalam, by heavily drawn from Kanakkatikāram and other texts. He remarked that Kanakkatikāram was a text which learned by students in traditional schools. That is the one evidence we have. There are other kind of signification also we have.
And one more question. Are there any cross-cultural exchange of problems from Egyptian, Sumerian, or even from interstate, such as texts of Karnataka, Tamil Nadu, found by comparison of similar problems in those texts?
Exactly, we cannot know kind of a if we consider a exact representation of a non-Malayalam mathematical problem in Kanakkatikāram. We cannot find that. But as a universal idiom, the subjects circulated in a complex network. So we can see a similar kind of, not in a similar language, not in a similar idiom, not in a similar socio-political context, but we can see certain kind of content in other languages too.
Another question by Pooja Priyadarshini. It also contains multiple questions. Was this performance part of pedagogy? If so, since you mentioned about the caste, who the teachers were?
I didn't get to please. Can you please read once again?
Was this performance part of pedagogy? If so,
Okay.
since you mentioned about the caste, who the teachers were?
As I mentioned, these teachers most probably came from a non-elite lower caste background. Eഴുത്തച്ഛൻ, Kaniyan, Panikku were the teachers who teach and composed. Then because this is not a reproduction, rather it is a recreation always. So they compiled words for their own purpose in certain level.
How was the performance carried out, orally or textual?
In certain evidence which we find out from the work of Thambi, he, as I presented, he narrated that there was a practice of singing of arcane words in front of a audience to prove the veracity of the performer. If we think in that line, it was a performance-oriented orally. At the same time, it perhaps lead to the writing of new kind of verses because performance demand an improvisation. So that improvisation may reflect to the reframing of or framing of new verses itself.
And one more question by herself. Competitions were also part of late medieval Kerala. Was this also a part of it?
We cannot categorically say that, but we can assume that it is a possibility. We have a perhaps perhaps we have a possibility to see these things in that line.
Next question by Anunand. To what extent this study occupy a critical position with regard to colonialism and predominant Eurocentric approaches followed afterwards in determining the later social structure, even that of our times? May I read once again?
Yeah, sure, please.
To what extent this study occupy a critical position with regard to colonialism and predominant Eurocentric approaches followed afterwards in determining the later social structure, even that of our times?
Actually, we need to ask the question itself has certain kind of an answer actually, because it presupposes that colonialism and its epistemological practice restructured social order in a nuanced manner. If we think in that line, we cannot see anything other than that. While we are researching on the past. But instead of that, if we keep to see what are the nuances of the past, what was the mode of articulation and expression of knowledge were existed in our pre-modern times, we could see the knowledge power dynamics in a very different view. As we mentioned in this study, in several paragraphs, this study is not a direct answer to the question of colonial epistemological domination.
Next question by Sadiq. Will these texts reveal something more about materiality and objects that intersect in our lives?
Sure, but for example, if we take the case of, as I discussed in the last part of the paper, the ecology, the paddy production, the land of paddy production is some way influenced the notion of measure itself. Moreover, if we take the case of wood calculation, if we compare the Malayalam Kaṇakkatikāram and Tamil Kaṇakkatikāram, we cannot see wood calculation in Tamil Kaṇakkatikāram. Instead of that, Tamil Kaṇakkatikāram discussing on granite calculation. Why in comparison with other mathematical treatises of Indian tradition, why wood problems are very much in number and in volume very much discussed in Kaṇakkatikāram? Because as M.G.S. Narayanan and others mentioned, our use of granite was very less due to many reasons. One is that availability of granite was not much. At the same time, because of the many rivers, we cannot transport granite from hilly regions, western hilly regions to here to the coastal and midland. So wood was at the same time, these rivers, the river help us to transport the wood. So wood become a commodity of our existence and being through the ecological force that lead to the wood calculation. So the affordability and property of the material and the force of the ecology is determined this mathematics in certain way, but it is not very much visible in text.
One more question by Sadiq. Will this text hint in locating multiple sources of science and technology?
Yeah, it is. For example, we have a interesting part which discussing the 2 or 3 verses that discussing about melting and assaying of gold and cutting, sawing and processing of wood and this cultivation of paddy and all. This in some way this reveal certain kind of ecology of knowledge production. How this ecology produced help to produce this kind of knowledge.
Final question by Anakha. Could you please explain the connection between Kanakkatikāram and Kanakkatikāram, if there is any?
Kanakkatikāram is a text which written in Manipravalam language. Manipravalam language is a mix of Malayalam and Sanskrit. We know that. At the same time, the introductory verses of Kanakkatikāram and Kanakkatikāram Balaprabodhanam mention that this text is written based on Kanakkatikāram and Leelavati. But in my examination and the Roy Wagner also mentioned that the influence of Leelavati on Kanakkatikāram Balaprabodhanam is a name dropping. That means very less in actual sense. Many of the problem which available in Kanakkatikāram Balaprabodhanam is took from Kanakkatikāram and articulated and framed in a new language. That means in the language of Manipravalam. But at the same time, the sections of the Balaprabodhanam, that means Kanakkatikāram Balaprabodhanam, is ordered based on rule of 3, rule of 5, rule of 7 kind of mathematical procedures. This is the difference between and the relation between Kanakkatikāram and Kanakkatikāram.
Ganeshan sir, please.
Can I make just 2 comments? This Ganesh, the so-called chairperson of the KCHR. Anyway, the two comments are, one is regarding the sources of this kind of texts. There seems to be, I happen to have read the Kanakkatikāram. I'm using my memory of that particular text when I mentioned this. One is that there seems to be a more closer connection between not the Sanskrit texts, but the two texts which have come to my mind. That is, one is the Abhidhamma Buddhist text called Uggala Panjati. That is one. And second is the Jain Bhagavati Sutra.
Excuse me, can you pronounce it again?
Uggala Prajnapti. Uggala Prajnapti. It is a Buddhist Abhidhamma text. And the other is called Bhagavai or Bhagavati Sutra. Now the point is that these two texts contain extensive calculations actually on material things. I mean, they are not concerned about astronomical data or anything. They are basically concerned about material objects and things, and they also do simple, what they call multiplication, division, everything, and also try to classify things into various grades. And this same kind of classification seems to have been used in texts like Kanakkatikāram. That is one. Because the point is that in the actual medieval times, the lowest quantity that is used in the medieval inscriptions is Mundarikai. But this goes much below Mundarikai and uses grains and anus. And that is very, very interesting, primarily because this kind of grains and anus are found in the Jain and Buddhist texts and not in normal texts of this thing. That is one. Second thing is that the biggest quantity, that is Vellam and Pralayam, these two quantities, they are actually not quantifiable at all. And these two biggest quantities are also mentioned in the Jain and Buddhist texts and not in other places. It is quite possible that these texts were actually rendered into what is called Padinankil Kanakku in Tamil. And Padinankil Kanakku consists of a number of texts which are possibly Jaina. Possibly Jaina, and that sort of translated itself into a later mathematical treatise. That is one possibility which I'm I'm not saying that this is an argument or anything. This is a possibility which one can explore. That is one.
That's good.
The second point is regarding the type of people. You talked about Kaniyan, Panikar, and other people who actually did calculation. That is possible. But what I'm trying to say is that the type of exercises that are collected in the text, along with the type of information that is also gathered in it. The point is that there is a possibility that it is not only the trade aspect, which you pointed out correctly, trading is very important, production is very important, but the same type of work is actually done inside the temple treasuries, which is very curious because the temple treasuries actually collect a large amount of, particularly paddy and other condiments, and they classify it and calculate it and use all the instruments that are mentioned, that Edangari, Nadi, Para, etc. All these are used inside the temple instruments. And the interesting point about this is that temple calculations actually vary also. It varies from place to place, primarily because of not because of the nature of the actual quantity that is involved, but the weights that are involved. For example, paddy, if you are collecting paddy of a particular kind, the weight of that paddy will change from one particular place to another. Another type of paddy will have a different weight.
Yeah, sure.
These kinds of minor changes in weights are not represented in your Kanakkatikāram in a serious way. But when it actually is calculated, the weights actually change. And this results in different kinds of measures for the same measure. The measuring instrument and the measuring vessel will change. And there is evidence for such change in measuring vessels and measuring instruments, primarily because of the fact that the way in which they measure will be different from place to place. It's as a result in number of paras, for example, like Kanakkatikāram para, Perumal para, and different kinds of paras are used in different places. And this shows that, you know, the measurement may change, which actually makes the mathematics more corresponding to the reality more than possibly an abstract mathematics can correspond.
Yes.
This is something that one can look into. This is something that is very interesting to me because they are not looking into the abstract mathematics or integers or anything. The theory of integers are not very important there. Instead of that, they are actually counting the actual, you know, material object, whatever it is. You talked about wood, you talked about granite, there is water, there is also other kinds of sand, for example, and they are only counting the material objects and calculating on the basis of that. What is this kind of mathematics and something that has to be looked into? I think that is possibly because they are relating it to more to the question that is asked. That is the materiality of objects which they are calculating. Instead of going in abstract, more abstract things like astronomy or astrology or anything. There Kaṇakkatikāram, I don't think it mentions any astronomical details. I don't know. I don't remember. There are any astronomical details in it? No, I think. This is something which I wanted to. This is something which is very interesting to me. And finally, there is a relationship between Enjuvadi and Kanakkatikāram. Is it not so?
Sir, Dr. Arun Ashokan has left the session. I
see.
think it may.
Okay.
Okay, he has rejoined.
Please continue.
Yeah, I completed. I only talked about relation to Enjuvadi seems to be a condensed Kanakkatikāram. You see, Enjuvadi, I have seen this Enjuvadi of early 20th century. That is actually a condensed Kanakkatikāram, in fact.
I agree with the first thing because there was a possibility of Kanakkatikāram's relation with the non-Brahminical kind of knowledge. For example, the Jain Buddhist kind of practice.
They are non-Brahmin. They are just Jain and Buddhist. Why do you call it non-Brahminical? Anyway, that's okay.
Because the second thing, about the temple kind of treatise, there is because first of all, Kanakkatikāram doesn't have any evidence about temple or there was some Brahmasam kind of land holdings and kind of earlier kind of temple management and other. Second thing, we have a great deal of paddy calculation and rice calculation, which is closely related with the paddy trade, because as we know very well, our production of rice was not sufficient in medieval period to feed the population. So if we go through any kind of medieval sources, we can saw that rice was imported from Orissa and other places, for example, from Ceylon and other countries to Kerala. So the rice calculation which is discussed in Kanakkatikāram is closely related to the rice trade. rather than we are discussing in the basis of evidence rather than temple. Temple kind
I
of.
talked about Nadi, Adangadi, and Para.
Yeah, Nadi Adangadi, Para also in trade also. Then at the same time, it is existing in because as you mentioned, I go through the what we can say, Vanderi Grandavari and different kind of Gandhavaris which are available to us. I saw this all kind of measures which you mentioned in these Granthavaris, which.
Yes. Yes.
But at the same time, we can see this kind of remark in trade manuals also.
Okay, I didn't dispute it at all.
So
I only pointed out that such calculations can be done anywhere. That's all I am saying.
yeah, that is true.
I didn't say that one has to mention there was some Brahmasma and all that in a mathematics text. There is no need.
No, but we have
There is no need. It's not a historical text to mention any of these things.
For example,
so there is no need for such things.
We have enough evidence about trade actually. That is what I'm saying. So we have a close relation to that is the thing. There was a knowledge existed with the medieval temple-oriented economy. We don't have any dispute about that. But Kanakkatikāram is not directly related with that. There was that is the point I am trying to make actually. Okay.
It's okay.
Dr. Dineshan, would you like something to be added?
No, thank you. I enjoyed the presentation, and I know that Arun is a bit busy and he has to attend some other important things related to his personal matter. So I think I won't make any comment right now.
So now it's the time to wind up this program as the speaker has some urgency to leave the session. Thank you, Dr. Arun Ashokan, for agreeing to be part of our webinar. Thank you, Professor Ken Ganesh, for chairing the session. Thank you for the participants for actively taking part in the program. And finally, thank you for the entire KCHR team for supporting me for coordinating the event. Our upcoming webinar is scheduled to be held on 22nd August by Dr. Muhammad Shafiq on the topic, The Archives in a Borderland. All are invited. Thank you.
Thank you.